Let's see how to make a hinge joint in Plasticity like the ones that I use in my toy robots. As always, starting with a new scene here, sending this through the perspective camera, and I am going to start actually with a sphere. Yes, ladies and gentlemen, I am going to start with a sphere. So I'm going to click in the origin, and I'm going to drag out, hit tab, and I think I'm going to make it for the hinge. Well, obviously it depends on how big your joint needs to be. Mine are around 6 millimeters, so that's what I'm going to do. Hit enter. Then I'm going to go to the side view, and I am using a sphere because I noticed that compared to the cylinder hold, the sphere creates a little more drag. So the joints, especially if you print them in PETG that is, are going to hold a little longer. So that's the whole reason behind it. Then I'm going to take my center circle from the origin. I'm going to go out, and I want, so this was around 6 millimeters. I want at least 11 here, so at least 5 millimeters, because otherwise the joint is not going to hold at all. And I'm going to make a support for this. Obviously, it can be anything you want on this side. It can even be this size. It doesn't really matter. I am going to make it the way I usually make them. So I'm going to start around here. I'm going to give it a little bit of clearance. Say something like this, hit C, and then while hovering on this intersection here, I'm going to press Shift. This is going to give me a guideline that I can use to drag exactly the same size as that, because I want them to be the same size. Doesn't really matter how long this is. I'm going to hit G when it's done and move it back around here. So I'm leaving this clearance here, probably even a little less actually, because I want this joint to not be completely straight. Otherwise it wouldn't have space basically here and here to move. I'm going to select all of these, and I'm going to push them out, hit tab so that it's doing it on both sides. And I want this to be about 4 millimeters, I guess, in total. So I'm going to set distance to 2 times 2 is 4. Hit enter. And now I've got the basics of my joint. What I usually do here is, well, first remove the curves that I'm not going to need anymore. But I tend to fillet this area so that the joint is not going to snap that easily. Then with this one selected, so for select this, I'm going to Q Boolean this ball and hit T so that I preserve the ball because I am going to need it. Pressing enter will effectively remove the ball from this. And now what I want to do is cut a chunk out of this. So C to cut with this line selected. Click that and confirm. I'm going to select with for object mode this, remove it to this and remove it. Selecting this face and pushing it, look at what happens. So we can see the ball starts to appear because we have effectively removed it from this solid here. So I'm going to go through until I get rid of the connection between the two. I suggest you don't go much beyond this point because otherwise it's not going to have enough grip. So something like this is going to be okay. I'm going to isolate this object. Doesn't matter whether you select the face or the whole object. As long as something belonging to the object is in the current selection, you hit period on the keyboard and it's going to select it all. I'm going to press 2 to go to edge mode or curve mode and select all of these. I'm going to hit B to bevel, and I am going to create a chamfer here that's about -0.4. There you go. So this is pretty much the same as the one that I have for my Mech. Let's go back. So let's unisolate this. And technically speaking, you can now play around a little bit with the size of the ball, because I noticed that at least for my personal case, for my 3D prints, making the ball with 0 tolerance is still not strong enough. So what I did with mine was increasing to something like 6.2. You can go as far as making it 6.4 or something like that. You're going to have to play around a little bit with tolerances by testing your own printer, but we want a firm grip. So I'm going to make the ball slightly bigger than the socket. So confirming that. Now I am going to make the other part of the hinge. So this was the part that's holding the hinge basically. And now I am going to make a rectangle here from the side view. So starting from the center again, hit C and extrude out. Let's actually enter, confirm that. Let's select this and solo them with period so that we have a clear view of that. So this is being created properly. Let's unisolate a second. I want to move this from the top view far away enough from this edge so that it doesn't brush against it when moving the hinge. So I'm going to move it. This was about 2 millimeters, so I'm going to make it probably 2.1. I think 0.1 clearance is enough. Again, you're gonna have to play around with it a little bit. Then select this face, push it, and I found that around 1.2 millimeters is enough. You can probably get away with 1, but again, that depends on the type of hinge that you want to make and the scale of your model. So selecting this one, I'm going to Alt X and X so that it creates it on the other side as well. Now I'm going to go back to the side view. And one thing you can do if you really want to be fancy is take the ball, Alt D to create an alternate duplicate, and cut with C the original squares here. Let's select this again, cut this, bam. By doing so and removing these parts, now this hinge, if I select, let me merge these first, QQ, QQ. So if I select that far away, this, and this, and I solo them with period, you can see it's got this kind of nicer edge instead of being square, which might impede movement depending on what you attach to the other side of the hinge. For the top and bottom, I basically want to make this printable. So right now, this cannot be printed because if we print it this way, it's going to start printing in the air over here. We cannot obviously print it here because it's curved. And top and bottom, obviously, it's going to have parts that are cantilevers. So we want to extend these close to the sphere enough so that we can cut away part of the top or the bottom. If you want this to be symmetrical, you can do both. What I do usually is cut the bottom. So I'm going to select the sphere, hit C and select the bottom face of our side panel, enter, and it's going to cut away that part. Now we can print this with this orientation. Then we can extend these obviously as much as we want to make whatever mechanism we want. But this is essentially done. A couple of things that you might want to do to make this a little more versatile. First, if I unisolate this, you want to make sure this thing here can actually swivel around. So if I go to side view, press R and then V so that I can change where my pivot is. If you put it in the center of the sphere and then rotate around, you can see you can basically simulate how the hinge is going to move. You want to check basically how much clearance you need before you can close this. This is obviously going to depend on the range of movement that you want for your hinge. Something like this is probably enough for me, so I'm going to make maybe a millimeter wall there. So I'm going to escape because I'm going to leave that where I was. And here on this side, Control R to isoparam, Tab to change to vertical, and I am going to put it around here. I'm going to eyeball it because it really doesn't matter. Extend, select object mode again with 4, the ball, the side panels, QQ, and now these are a single object. You can always move this, obviously. Select this face, you select this one, G, you can move it around like that. But say, what if you want to take this one, and for any reason, let's say you make a complex part, and you want to print it this way. That's going to be impossible, because right now, the ball cannot be printed that way. So let me isolate this real quick to show you what I did for my own, because I needed them to be printed on the other side. So I'm going to cut this with C, cut this with C, and now I can rotate the ball freely around. So I'm going to rotate it 90 degrees. So we can see that side there. This is still unprintable because once again, there is nothing here unless you want to use supports, and I don't recommend that. It's going to print in the air. So what you can do is either you push this up so that it basically creates a plane that you can use. It's still not ideal because it's going to spaghetti a little bit around this. It's a curve, so it's not going to be the best. Or you can select the center circle, go to the side view, and let me remove that rotation because it seems that it misaligned it. So I'm going to use my center circle and create a smaller cylinder, something like this for now. So I'm going to solo this. I'm going to extrude it tab on both sides, making sure it pokes through for now. So what you want to have is basically a cylinder that you can see from here. Something like this is probably okay. Then I'm going to solo this and rotate it properly. So side view, R, V, you see that was not the center, so I'm going to center it again and rotate it 90. That was my mistake. There you go. You always want to make sure the rotations are right. So if there is anything you see is not rotated properly, it's going to be very hard for you to bring it back to normal unless you Control Z. So make sure you always triple check. So now that we have that cylinder, we can Q that, Q, together. We can remove that extra part. So I'm going to remove this, and we're going to remove that. C, remove. I'm going to Q them again. And I'm simply going to push this so that we can have at least a little bit of support over there so that it creates this bridge. Again, it's still going to spaghetti a little bit, but it's not going to be as terrible as printing in the air like this or like this. Another thing you can do is reduce the size of these even further so that you don't have the overhang. So push this down. Let's see if I can do it properly. Something like this, very close. Reduce the size here of these overhangs as well. It's obviously going to glitch now, but if you do it from the very beginning, it's not going to happen. And then you can print it with the bottom here or here. So up to you. I found that unfortunately, if you print it this way, the hinge itself tends to swivel from side to side. So you're going to have to test a little bit. My preference is honestly to print it this way. You can even make these a little bigger so that you have a little more room to keep hold of our other side here. So just one last check here. Select this object, RB, to move the pivot, set it in the center. Does it have enough range of motion? I would say yes, so it's going to stop right there. And we are basically done with our hinge. If you enjoyed the video, hit that like button and subscribe for more. As always, thanks for watching, and I will see you next time.